Tide current tables. Practice problem 3. What will be the velocity of the tidal current at Port Royal, VA at 1505 DST on 4 June 1983? Let's look into that. We need the velocity of the tidal current at Port Royal, VA. Port Royal, VA at 1505 DST on 4 June. At 1505 DST, that's important, 4th of June. Let's set this problem up. We'll need our reference station. Reference station, what's that equal? We'll need our time differences, our speed ratio. In these time difference, we'll need minimum before flood, minimum before ebb. And for the speed ratio, we will need flood and ebb. Cool, now that we're set up, let's jump into table 2 and look up Port Royal. Here's the P's. Port Royal. Port Royal is 5261. 5261 in the index. So we'll jump into our table 2s and find 5261. Okay, here they start. 46, we already passed it. 51 and 53. Good. Here we are in table 2. We cruise down this side and we find 5261. There we are. Port Royal. And if we follow this column up, Chesapeake Bay entrance, page 64. There's our reference station. Chesapeake Bay entrance, page 64. And here's our 4 columns. Minimum before flood, minimum before ebb. Minimum before flood is slack. Flood is a max current. Minimum before ebb is slack. Ebb is a max current. Conveniently, all of these are 610. That doesn't often happen. Let's record those. Plus 6 hours and 10 minutes. 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 And our speed ratios, see, speed ratio flood, speed ratio ebb. For the flood is 0.7. For the ebb is 0.5. And let's put in DST right now. We need to add an hour to all of these. Add an hour to all of these. If we add an hour, it's pretty simple, straightforward. It's going to be 710. Plus 710. 710. Okay, now we're set up for basically anything that comes our way. So let's go to page 64 into table 1. 48. Oop, there it is, 64. We start in January. We are looking for June. So we go January, February, March, April, May, June. Here we are in June. Our time differences are quite substantial. So June 4th. All right. You see this 940? That is a max current time. It's an ebb, 940. That value would go here. 940 plus 710 is going to be like 1650. Yes, that lays on one side. So we're going to be in here. Let's just record what we need. So 545, and then the max ebb is 940, 940, and the ebb current is 1.0, 1.0. That math is easy. These are ratios, so we multiply any of these speed ratios. So anything times itself, times 1 is just itself. So 0.5 times 1 is 0.5. Good. Now let's crunch these numbers. 0 and 5 is 5. 1 and 4 is 5. 7 and 5 is 12, 1255. And the ebb, 0 and 0, 0. 1 and 4 is 5. 9 and 7 is 16. Excellent. Now we can get into our table 3. Before I set up table 3, I really like going there. It's on page 190. Because if we go here, we can see what we're looking for. We can see that we're looking for interval between slack and desired time. Interval between slack and desired time. What's that equal? That equals interval between slack and desired. So slack is the minimum before ebb, that's 1255. Our desired time is 1505. I always put the big one on top. 1505 minus 1255. We'll get an answer, maybe leave a space. And then we're looking for this. Interval between slack and max current. Interval between slack and max current. What's that equal? So the interval between slack and max current, here's our slack and our max current. I'll put the big one on top, 1650 and 1255. 1650 minus 1255. Okay, let's crunch these numbers. We can't take 55 from 5, so we're going to borrow. 14, we're going to borrow 60 minutes. So put that in there. 5 minus 5 is 0. 6 minus 5 is 1. 4 minus 2 is 2. 1 minus 1 is 0. 210. Okay, let's do this subtraction. Well, we can't take 55 from 50. We're going to borrow. And we're going to borrow 60 minutes, right? Which would make 60 plus 50 is 110. But we're going to borrow. So essentially it's going to be 10 and 10. So 10 minus 5 is 5. 10 minus 5 is 5. Good. And 5 minus 2 is 3. 1 minus 1 is 0. 355. So now we have our intervals. Let's see what table 3 spits out. Table 3 is going to give us, we enter into the table, interval between slack and desired time. Interval between slack and desired time, 210. So we have a 2 and a 220. We're right in between those. But I'm going to keep it under 220 so we can see all the values. And now we come in from the top. Interval between slack and max current. All of these numbers up here. Let's line it up. Interval between slack and max current, 355. Okay, that's almost 4. So we go down this column. We get a ratio of 0.8. 0.8. That's the ratio we get from table 3. So we take what we calculated up here for our max ebb, 0.5, 0.5, and we times it by this ratio, 0.8. What does that give us? 0.5 times 0.8 equals 0.4. Gives us 0.4 knots is the velocity of the current at Port Royal, VA, 1505 DST, June 4th. Let's check. Number 3, see C equals 0.4. Let's check C. 3 should be C. There we have it. 3 is C. I will see you guys on practice problem 4. Let's just keep chugging through these. We'll get there.